Hello and welcome to Any Combo Lords. Today, as the sun rises, which it's already doing, and it's a little foggy or cloudy out, so we might not get quite a magnificent sunrise here, we're starting off in my front yard. You might know my backyard a lot better. That's where there's a little corner that I've created my combo classroom with all the clocks and dice and such. But it's still nice to catch a peek at the front yard that I do share with some family and some neighbors who I don't know super well. But still a nice little garden. Got a cat over there who was recently adopted into the family. And I'm going to pull open on my phone the stream as well to have the chat going. To anyone joining me in the future, there will be some timestamps and chapters of the different things I'm going to talk about today, so you can hop around. And to people who don't have like an hour or two to watch my super long streams, they can pick and choose what parts of the ranting, math, storytelling, or little activities that they want to join for. And cool, just double checking that we are all good to go. Welcome to everybody here. And some things we're going to talk about today are the nice sunrise, a new plant that's in my garden, some funny stories from the month, some plans for next month, and some little mathematical tidbits. To start off, let's note that we're nearing the end of January, getting toward February. And February this year has 28 days, one of those non-leap years, and 28 days has shown up in 2 of my episodes on the main Combo Class channel, which actually just hit 24,000 subscribers. And since that's really my main passion project, and this is sort of just my fun personal channel almost, that's the channel I'm extra proud when it hits those milestones, so that's cool. But it's come up in 2 episodes, 28 days, once in a mathematical context and once in a context of what calendars maybe should be, which is a mix of maybe math, science, history, and all sorts of stuff like philosophy. So I realized a little link between 2 episodes I need to note here is that February having 28 days has exactly 8 factorial minutes. And let's see why that makes sense to be the case. Let me actually shrink my face a little bit, and we're going to pull open like Wolfram Alpha or something, and look at what makes up 8 factorial. Well, 8 factorial is multiplying all the numbers up through 8. And do they have its prime factorization here somewhere? Let's see. More. We want more representations. No, that might not be there. Maybe if we ask it. Prime factorization. And it does have that. So here we got a bunch of 2's making up this number because we've stacked those in the 2's, 4's, and 8's that hit. That's why in my video about zeros at the end of factorials, we only cared about the 5's because 2's and 5's making zeros in our base. We're going to have more than enough 2's. 5's were the factor that were limiting us. So we got 7 2's, 2 3's, a 5, and a 7. How does this make up February? Well, the 7 is how many days we put in a week. Let's take 2 of those 2's. And now we just have 5 2's left, and 2 of the 2's make a 4 weeks. 4 times 7 is how many days are in there. And within a day, there's 24 hours. 24 is 3 of those 2's and 1 of the 3's. So now we got 2 2's, a 3, and a 5 left. And those happen to multiply to 60, the amount of minutes in an hour. So when we juggle these numbers around, we can either make it into 1 times 2 times 3 times up through 8, or make it into 60 times 24 times 7 times 4, which is how many minutes February has on a non-leap year. And that was already noted in my factorial episode, but what I realized is that in my calendar episode, we were talking about how the International Fixed Calendar is a proposal that's a 13-month calendar that actually works more efficiently than a 12-month calendar, arguably. Although I had my own proposal, which was 12 months at the end, the 13-month is easier to convince the world of because it does contain the 7-day weeks still. And in the International Fixed Calendar, apart from these special holidays, Year Day and occasionally Leap Day, every month has 28 days. So I just realized that in the International Fixed Calendar, that's an extra fun fact about it. Every month has 8 factorial minutes. Another reason we should switch to it. And then maybe I'll get people to switch back to a 12-month calendar, because I kind of like 360 days being the main way of splitting it up, and just figuring out something fun to do with those other 5 to 6 days. Scatter those on the equinoxes and solstices for some weird holidays or something. So that's a little fact about how many minutes our February will have. What about February plans for combo class? Well, we're nearing grade -2. I've decided that on the main channel, which is sort of where I measure where we're at on the grade, because although this channel has a lot more content on it, I'm less perfectionist here. I just do more random stuff, my live streams, my shorts, my bonus videos and such. And on the main channel, I make sure I get each one as a little concrete learning fun block, and a mix of learning and like an episode of a TV show that's hopefully fun to watch. And there is going to be the base 6 100. 100 in base 6, they should hopefully know is 36. They're doing this different. They're saying, let's see, convert. They're saying what is the number 100 of a thing, how base 6 writes that. I meant the other type of question. What does base 6 call that? But yes. If we did it opposite, if we asked them what's 36 in base 6, they'll tell us it's 100. So that's how many episodes will be on the main channel, and that includes like a first little silly intro and all of the others I've made, which have been 30 episodes total so far, and 6 to go. And the last one will be a longer finale of sorts. I'm going to compile a bunch of behind-the-scenes stuff that's happened, gather some of my philosophical thoughts about what it meant to make this grade, and it also will have some hints of some crazy sagas from my personal life, which it's not going to go into the full insane stories that happened to me about 2 years ago, but there were enough insane stories that happened to me within the time I was making grade -1 that I had to get 2 surgeries, for example, so you're going to see some insane x-rays. So yeah, that will be a personal dive. And while I'm compiling that, I will be sharing a lot of it in advance with my Patreon supporters. Because thanks so much to the people who are supporting me on there. I've been putting your names, even the lower tier people, in the descriptions of the main channel videos, and I'll put them in some bonus ones too. Might not always be able to put the lowest tier people names in the descriptions, but for now there's room. So for now you're all getting in. And the upper tier people, sometimes even in the credits and stuff. I haven't posted that much behind the scenes stuff on Patreon this month, but I'll make sure to get a good amount next month, including one of the things I'll drop there that sometimes I'll put out things on Patreon sort of as my rough version of something I might release to the world in the future, including something people have requested, which is the Combo Class soundtrack, which are the beats I made that make up the main channel episode back soundscapes. So I'll probably put out like the current version of the beats I have on the Patreon pretty soon, and then get somebody to maybe mix them a little better and release them in a better way in the future. I need to work again with some more musical people like I have in the past. I used to do a lot of music recording, and there's a lot of rare music from my past I have to show you guys, but I also want to record some new music. And so, warning, there may be music videos and things that are also music theory lessons on this channel sometimes. This is sort of just my casual Demotro channel, although I'm calling it Combo Class Bonus right now. I may even just rename the channel to just Demotro at some point, because this is sort of my personal channel, and I do love talking about all the Combo Class stuff anyway, because that's me and my show. So it's going to be very similar, but On this channel, we may see more music and weird stuff like that going forward. In February, in addition to that, within these 6 main channel episodes that are remaining, they're going to be really cool math concepts. I'm going to be filming part of one today. I have a camera guy coming over in a couple hours, my friend Carlo, who filmed most of the recent main channel episodes. And we're going to work on a cool one today that I guess I'll give you a little preview, which is today's topic is going to be about these things I've mentioned in a few shorts called pan-digital numbers. Numbers that in a certain base contain every digit. And part of that is just that there's some fun examples of random pan-digital numbers that I want to share traits about, that a random one of them that happens to have some cool trait. But another part is that they're actually more fundamental and important to the concept of counting and to a number line than people realize. In a given base, which numbers would be pan-digital and where they lie on the number line actually opens this whole interesting, deep question. And it turns out that I needed to make this episode before I make another episode that has also been highly requested, which is about infinite series of fractions and adding up infinite series of things and which ones converge and which ones diverge. Although that sounds like a completely unrelated topic to these pan-digital numbers, it's actually secretly pretty similar and needs to follow second after that, because the first one needs to introduce some interesting concepts about them before they can be ready to be flipped into fractions that have an interesting trait. So those are 2 of the episodes that will be coming out in this grade, as well as one about dice that I've been planning for a long time, one about a mix of language and math that I've also been planning to put out in this grade for a while, and 1 or 2 more, including that long finale. So the episodes on the main channel that remain might all be more like 20 or 25 minutes and more like 10 days apart. They're going to be a little more spread out and a little longer, but they're really cool because I had too many topics to fit in grade -1, and some of these are the topics that I just couldn't not put in grade -1. I'd been wanting to do them all grade, and I had to sneak them in here somehow, but I saved them for the end because there were so many fun facts about them that I had to make sure I got the episode right, or make sure that I had it brainstormed in the right way of mechanizing the thought process and leading the viewer to the cool conclusions. So these are some of my favorite topics coming up. And there's also plenty of awesome topics that did not fit in grade -1. I have some topics that are just like magnificent things. Some of the things that I've personally discovered even didn't make it into grade -1, where I've done a lot of my own mathematical investigations and found some pretty cool patterns. And some of the things I've personally discovered, one will show up in the episode about homemade dice that have this paradoxical trait, but others may have to wait till grade -2 and have some really cool patterns that I personally discovered to share with you guys. And in grade -2, some overall goals are to not change the vibe of my presentation or my learning while still managing to somehow up the production quality a little. I want to be able to have slightly better audio, more different angles of camera, more little cut scenes of visual representations of stuff, more field trips to cool locations. So I want it to be more visually engaging and the audio to be a little higher quality and stuff, but we're not going to lose our homemade edge. There will still be all the chaos because I am a chaos magnet, so it's going to happen. For example, when we hit grade -2, it's somewhat like hitting noon or midnight on a clock. And there will be some resets. Some things will still be there. I'm not going to remove the dice from the dirt. Some of the clocks will still be on the wall. Some of the clocks will have to be thrown away because the rain destroyed them. But other things will reset. There may be a new desk, a new lab coat, a new haircut. I'll look a lot younger and cleaner when grade -2 starts. Might catch you by surprise. I like to let my hair and beard grow super long and then cut them super short. Ride all types of the wave. So, might catch you by surprise, but for anyone who enjoys the chaotic side of it, it's not just grade -1 you'll like. I'm guessing that most grades are going to have some sort of pattern where the desk breaks somewhere around 6 o'clock on the modular cycle and the lab coat's burnt by the end of the modular cycle and so on. So, to those who like the cleanliness, you may like the first half of each grade better. And to those who like the chaos, you may like the second half of each grade better. And to those who like the whole arc, watch out for all the interesting lore, because, especially on the main channel, all of this is going interesting places. All these topics relate to cool findings that I've found, cool stories from my life and things, and we are going to go further and deeper in grade -2, while still being silly and having fun. Every 5th episode or so is still just going to be a silly scientific snack break. So we're still going to have a similar vibe, but hopefully a slightly higher production quality. And before then, we're sort of ramping up to that. My classroom's a bit destroyed, and we're probably going to head there in a second. I'll bring you guys back to my classroom, and we'll note that the rain has somewhat trashed the area. As I'll mention in the finale, I somewhat intended certain elements, which are a theme throughout human existence and philosophy and science, to be in the show. And there are these classic 4 elements that there's a fun cutscene I made about them in my episode, The Mysterious Hyperdice Sequence, about how some old philosophers believed that these platonic solid shapes, these magical 5 things, apart from the 5th dodecahedron was a separate one for some reason, because there was only 4 elements and 5 platonic solids. They assigned 4 of the platonic solids to possibly being related to elements, like tetrahedrons were like fire, cubes were like earth. And in general, those 4 elements, whether you're talking mathematically or not, are a sort of fundamental thing throughout a lot of human culture, and probably even other animals that aren't human. I don't watch much TV, but a good cartoon is Avatar: The Last Airbender, and that relates sort of in ways to 4 elements. Another really surprisingly deep, magnificent show is Adventure Time. Might be branded as a kid's show, but it's actually one of the greatest shows of all time. And that also has its own weird twist of a sort of 4-element realm. So the 4 elements that we're used to have shown up throughout human culture nonstop, of earth, air, fire, and water. And I intentionally put the earth part in. We were going to do an outdoor classroom in the dirt. I intentionally put the air part in. We're going to have fresh air, sunbeams, reflections, bird songs, and stuff. And bubbles are my fun representation of visual air. I intentionally put the fire, you know. I burnt clocks to attract attention, to trick people to learn math and such. And I didn't intentionally put the water yet. I was like, maybe I'll save water as a theme for a future grade. Maybe there'll be a grade about flooding. Flooding has been a theme in my life. There was one time where I was feeling like my life was in this flood, and I was calling it the flood era in my head. And then my house's water heater broke and was right next to my room, and it literally flooded my room. There was an actual flood in my room. It was really surreal. The carpet had this wet spot because the water heater had broke and was leaking sideways and under in this weird way. And there was this wet spot on the carpet, and I thought something had spilled. And I kept trying to clean it up with a towel, and the towels were getting wetter and wetter. And I was like, what spilled? How much of something spilled? I've like put 3 towels on it, and now the 3 towels are soaking wet. how much water could have spilled in this spot? And so it turned out it wasn't spilling, it was continuing to leak. So there was an actual flood. And then I was like, we're past the flood era. We're on to new eras, such as this combo class grade -1 era. But the rain reminded me that sometimes these 4 elements are a bigger force of nature than I am. And maybe it wasn't even my choice to put them in. Maybe they just put themselves in. And maybe water decided to include itself because it rained a lot and that contributed to my desk breaking. Now a lot of the clocks are chaos. It is part of why all the dice are embedded in the ground. And here's Dandelion, one of my glorious cats. Dandy, you want to say hi to the stream? Dandy. That's a Dandelion. Hey, Dandy. This is the softest, nicest cat of all time, by the way. His brother Sage is very nice and very wise, and Dandelion is maybe a little less wise in terms of like book smarts, but he's very love smart. He knows how to get pets, and he knows how to be a creature of pure love. And so I'll be petting Dandelion down here while we chat. And once in a while, if people request, we can pan the camera over to him. Maybe I can get an angle where it's both of us. Dandelion, on cue. Okay. Dandy. Dandy. Dandelion. Alright, we're going to do a Dandelion break. Anyway, the end of that rant was that the rain unintentionally came and, well, it had intentions. I didn't intend it. And so it turned out that all 4 elements were a theme of grade -1, whether I wanted it or not. There was a lot of water in a whole saga of the main channel episodes that broke the desk. I slipped in a puddle, a lot of stuff. The yard flooded. So turns out that all 4 elements made an appearance, even though I had only decided to pick 3 of them, because the rain is a more powerful force of nature than me. So, let's get a little Dandelion time. We always need to appreciate the nice animals and plants around us. Dandy. Another cool thing I'll show you in a moment is whenever I'm interacting with animals, it does also remind me of plants because it's like nature and life. And there's a new plant right over there. Can't really see it because it's behind that bench. But when I take you closer, you're going to see a pretty cool plant that's going to create a vine, hopefully, that will end up being weaved through that fence and climbing all over it. So let's take a little look past our Dandelion. Hi, Dandy. Dandelion. Look how golden he turns. He was just pure black, but then he turns golden. Okay, so over here, right behind this bench, do you see this plant right here? This is a passion fruit. Now, down here, let me see how to get this angle. Down here, we can see that is a passion fruit. Not quite ripe, but pretty close maybe. And this is just a baby little passion fruit plant, but the vine may spread through the fence and grow upward. And there's these really cool tendrils the vine makes. Can you see this? These little spirals. Lots of cool little spirals on that plant. Dandy. Dandelion. All right. So now back to me and Dandelion. We're going to go back to the combo classroom soon. Don't want to disturb the neighbors too much. We do share this yard with neighbors, but my combo classroom is our own little realm. Although when I get loud there, I'm sure I'm disturbing other neighbors. Luckily, I've forged an alliance with most of my neighbors. I've chatted with various of my neighbors, and good to form alliances within your community. So they're okay with you blowing bubbles everywhere and ranting about math. So, speaking of which, I do happen to have my really cool bubble gun here, and since there's a little more space than in the combo class, maybe I need to show you guys a bubble in bubble out here, because there's a little more room to see the bubble in bubbles. Dandelion is going to be really weird. Dandelion thinks the bubbles are super weird. He'll like stare at them and be tripped out. So I haven't really checked the chat, but let me go through. Thank you all for joining me here. Someone wants me to explain Bayes' theorem. I'm not going to explain a random request from the chat always, but you can feel free to ask. Don't need to ask a bunch of times, but that one I don't think I'm going to spend today's stream talking about because I have other topics I want to talk about. If you want to see a good video about Bayes' theorem, I believe there is a good one on the channel 3 Blue 1 Brown, because Bayes' theorem is has some weird things. Probability always is, you got to be really careful when you describe things in probability because they're really tricky and weird. So, thank you all for joining me and leaving some random comments. We are going to take a little bubble break, and I'm going to refill this bubble thing right here, and we'll see if we can blow a bubble. Then we're going to go back to the classroom. Listen to those birds. Ooh. Isn't that wild? See that? Oh, I should move my cup of coffee. This is gonna get all bubbly. Whoa. Some of the clusters stay on the ground because it's kind of wet from like morning dew or whatever. Ooh. Okay, well, that one popped a lot of bubble juice kind of on the computer and phone. That'll be enough bubbles for the moment. Now, let's pop back to the combo classroom for a moment. And one moment. Someone said bubbles are fascinating, the physics and their applications are interesting. Very true. There was even a mathematical discovery in last year, 2022, related to this thing called the double bubble conjecture, taken further to like triple bubble and quadruple bubble conjecture in higher dimensions. And it's about minimal surface areas that things can make when they touch, very bubble-like. And we'll find reasons to use this in the future. So I'll definitely be researching bubbles to figure out ways to make it worth another episode about bubbles, because I want to do another bubble making episode sometime in grade -2, but I don't just want to be like, oh, we're making bubbles again on the main channel. I need to have a new level of math or science to present with it as well. So for sure I'll be researching what cool things bubbles can do this year. And someone wondered if combo lords include combo ladies or other non-binary combo beings. Yeah, combo lords includes anyone of whatever gender. So Lord does in history sometimes have like connotation of meaning the man side, like there's the lord and then there's the lady as separate things. That's not how I'm using lord. I'm using lord to mean like really good at using certain skill type of lord, like you're the lord of that skill. And so we are the combo lords, the ones who are really good at using or thinking about combos. And so combo lords includes anyone of any gender, but you can also call yourself combo whatevers. Someone's saying they've made a discovery about minimal polynomials. Sounds cool. And someone's wondering how you pronounce numbers in other bases. There's not really a formalized way to do that because none of the bases have become popular enough to have a formalized way. Certain systems have proposed, here's this way of doing it, or here's that way of doing it. So there are various proposals, but none of them are standardized in any way yet. So something's still open to interpretation. For example, whether if we switch to base 6, would 10 mean 1 0 or mean 10 of a thing? You know, we would probably still use 10 to mean 10 of a thing, but we would then need to reinvent names, like then 2 0 wouldn't be 20 of a thing in base 6, it would be a dozen. And so it's something we're going to have to work on as we shift toward hopefully a base 6 or 12 future, to try and hook people on more ways of pronouncing and saying them. Now, funny enough, one of the episodes on the main channel is about writing and spelling numbers, but it's sort of just a weird mix of math and language. It's not actually about different bases. It's just about what are the potentials of when you name numbers, what happens, which there's just some interesting rabbit holes to go down there. For example, there's a few shorts I made that I actually put them on TikTok a long time ago, even though I don't use that app much. I post my stuff on there. In fact, the one I posted a few days ago got 1 million views. So it's really hit or miss on there, but one of the latest ones is another one that got 1 million views on there, which is pretty cool. But I had posted a few shorts on there a while ago that I didn't put on YouTube Shorts because I might just wait to save the shorts until I have the full episode related to them come out, which will be pretty soon. And it's about if you alphabetize every word, what weird traits you get. I mean, alphabetize every number word, every name for a number, what weird traits come up. So, lots of interesting thoughts. Let's move back to the combo classroom, and then what I want to talk about back there is well, let's just move back, and yeah, here's what we're gonna do. I'll do an intro here so I can put something on the screen as I shift us. So, I recently made a short about these things called fairy series. Well, I often am tempted to call it a fairy series because a lot of authors do call it that, but more technically it's a fairy sequence. So I gotta catch my tongue on that. Because series more formally is saved to mean when you add up a list of things, a series. So usually it's not 100% like this, but typically you save the word series for when you're adding up all the stuff, and when you're just making a list of them, you may just call it a sequence. And don't get started on when or when not to use the word set. That's a whole nother story. But for sequences, sometimes there's sequences that look like another, that the first 10 or so terms seem to line up, and then it turns out it wasn't the sequence you thought it was. Like if you were investigating some pattern about numbers, and you found when you plugged in 1, you get 2, and when you plug in 2, you get 4, and when you plug in 3, you get 8, and when you plug in 4, you get 16. You're very tempted to think 32's next, but it isn't necessarily the case. because there's a lot of what I like to nickname lookalike sequences. And I probably will at some point compile a bunch of my favorites into a main channel episode about lookalike sequences, as I call these. But I've already thrown a few in some shorts. Like there's one about a circle division problem that mathematicians love, where there's a very simple question about polygons that the answer's a sequence 1, 2, 4, 8, 16, 31. It falls short right there of the 32 you expect. And a similar one is in the short that I just made. Well, I filmed a bunch of the shorts I've been dropping a few days ago, but the short I just released about this list of what looks like the first prime numbers. But it turns out it's not. And here's how we're going to find an interesting connection is by looking at one of my favorite websites, the OEIS, the Online Encyclopedia of Integer Sequences. So I'm going to shrink and go to the OEIS. And right here, let's look at if I plug in what looks like the first primes. So we got 2, 3, 5, 7, 11, 13. And when I search it, the first thing we note is, okay, they got this sequence, one of the earlier named sequences, no surprise, the prime numbers. Now, I'm actually going to fully shrink for a moment and move to the back, read what they have to say about prime numbers, but after that, we're going to scroll down, because what could be below that? Well, below that would be other sequences that contain that string that start with 2 for the first term, or sometimes there may be a term before, but have in a row 2, 3, 5, 7, 11, and 13. So let's scroll down in a moment and see which ones may contain that. Now, I'm going to need to set us up somewhere better, but for now, we can reappear in the combo class. Teleportation activated. So, here in the combo class, I'm just going to hold my computer for a moment right here and guide you through. After the prime numbers, if we search this, okay. So, if we search the string at the beginning of the prime numbers, the next sequence that matches those numbers after all these notes about prime numbers isn't that interesting. It's the prime numbers at the beginning of the 20th century. Today, 1 is no longer regarded as a prime. But below that, we get number of fractions in Farey series of order n. They're even calling it a series. That's why it always throws me off. I think sequence does fit it better, like I've heard some texts say, so that we can save series to mean when we're adding them, but you'll see it called a Farey series sometimes like that. Now, here they say sometimes called this, but that's more like, it's more like the sum through this. This is often used, you got to be careful, sometimes just means the how many were added on each row almost. How many were coprime and less to it. But of course we know this can be used many ways in math. So it looks a lot like the beginning of the prime numbers. Missing 17. But all the way up through there, it's primes. All of these are primes. Just with 17 is the only missing one. And then you get your 33. And you're like, what the heck? That's not prime. That's obviously threeven. So, and it's 11 because it's a multiple of 11. Don't worry, we're not on a quest to get 11 in the dictionary. 3ven will be enough. So, sometimes a pattern will throw you off, and in fact, it's not only the farey sequence that does this. I've scrolled through all these pages, and there are more things. Some of them are just about primes, but some are different. This is, you apply the same type of prime hunting technique, but instead of crossing off every number, you cross off every so-and-so remaining number. And it like gets you all these primes until 19 and then glitches. And then here's cyclic numbers. There's, okay, careful with this word. This is another word that is defined, used differently in some other contexts. Other people use cyclic numbers to mean other things, so let's use this definition more than the nickname. These are numbers such that, two ways of describing. One is that there's only one group of order k, but we haven't covered group theory yet. I'll do that in a future grade. And then this is an easier way of describing it, is that the number is such that it and the number of things relative prime to it that are relatively prime to it are relatively prime, it looks like. So we get a lot of lookalikes of primes. What's this one? Numbers that are the product of an odd number of distinct primes. I guess that's just because you could count one prime. So that one's not that fun for why they appeared. Absolute primes. So there's a lot of fun lookalikes. And although primes have some fun ones, there's even... let's see, yeah. Although primes have some good ones, there's even more lookalikes for other things, like the powers of 2. If you search this, there are so many weird sequences that start with this. Some of them are a little more normal. And some of them are a little more random. What? Whoa. So, to anybody who wants to have some fun sometime, go through OEIS, look for some fun lookalike sequences to some other things. What is a lookalike to the triangular numbers or factorials or Fibonacci numbers or things like that? And if you find any cool ones, let me know in the Discord or subreddit, because some point I will make an episode all about some of the coolest lookalike sequences all put together. Lookalike sequences are also an example of patterns that break at a certain point, you could consider. And the pattern in this case being that it lines up with being another description of the powers of 2, or breaking meaning it separates and is a separate sequence, which also shows up in some other interesting places in math, such as if we look up the Polya conjecture. This states that this guy believed, which, you know, great people believe wrong things sometimes. Even Euler had some wrong conjectures. This guy's conjecture was that most, meaning 50% or more, of the natural numbers, in this case were like the whole positive integers, less than any given number, have an odd number of prime factors. And some describe this as the prime race, where if you're like tallying up which numbers have an even or odd amount of prime factors, then you have to go up and give them scores. And he conjectured that 50% or more would always be in the odd side. And it was proven wrong at a really large number. It was disproved. He showed that it has a
the conjecture has a counterexample, which he estimated to be around that size. Do you see that? That size. That is way bigger than like the amount of atoms in the observable universe. And here's an explicit counterexample. This one isn't bigger than the amount of atoms in the observable universe, but it's still pretty large for the smallest counterexample. So this seems to be true, that the natural numbers less than a given number have an odd number of prime factors until you get to 900 million. So if you were checking the first billion numbers, you'd be so sure that this seemed true if you were just going off your empirical data and didn't know how to prove it. And then you'd hit this number and be like, what? And in fact, it says it fails to hold for most numbers within this range. So there's a whole like 300,000 numbers that most of them don't follow the conjecture. And here's this fun one called the strong law of small numbers, which was named by someone called Richard Guy, who I really like this guy. Funny, okay, I really like this guy. He was really into like open questions in math, and that's also an interest of mine. He also co-wrote with John Conway one of my favorite books, the Book of Numbers. And it's a humorous law that where he proclaims there aren't enough small numbers to meet the many demands made of them. But it's actually from an article where the article's really good. We might have to do an episode about this whole article sometime. The strong law of small numbers. And this is where he's like chatting about some stuff, showing things like this circle division problem. And here's where he comes up with this joke phrase. I've been trying to formulate the strong law of small numbers for many years. The best I can do so far is there aren't enough small numbers to meet the many demands made of them. It's a funny way of phrasing something, but what he really kind of means by this is that when you see something happening in the small numbers and you wonder, does this prove anything about the big numbers or numbers in general? The small numbers can't really tell you about the big numbers because they're grains of sand in comparison. And so you kind of need to prove a pattern to really know it holds, because maybe it was 906 million that it breaks at. So this is an excellent article. Highly recommend it. And we might cover it on a whole episode sometime. Like I said, this guy's really cool for bringing a lot of attention to certain open problems in math. It's always good to be a thinker like that. Another great mathematician similar to that was Paul Erdős. However you pronounce it, Erdos. I've heard it pronounced a few ways. He was very into open questions and would even put like bounties on them where he'd be like, oh, I'm really curious about this thing. I'll give someone $50 if they figure it out. And if I was ever rich, I would do that. So that's some fun little tangents into how the farey sequence looks like primes as we go forward in what we're adding, but really that you can't tell by looking. So why do they add a certain amount each time is another question, and we will cover that in a full episode with a mix of some animations I already have. There's an animation on the main channel on this episode called something about spiky shapes, and it's about coprimeness. And there's a lot of patterns that relate to, for each number, how many numbers smaller than it are coprime to it. And we demonstrated that visually with some spiky shape animations. And they're going to come back not only for something about music theory, which, believe it or not, does relate to coprimeness, but also if we ever talk about these, because which fractions do you add? If I'm adding thirds, I get 1/3 and 2/3. But if I'm adding fourths, I do 1/4 and 3/4, but not 2/4, because 1/2's already in there. We're adding all the fractions possible up to a given denominator. And what we're adding are the ones that are coprime to the level and smaller than it. Like up to 4, 4 shares a factor with 4, so it's already on there. 2 shares a factor with 4, so it's already on there. 1 and 3 don't share a factor bigger than 1 with 4, so they get on there, 1/4 and 3/4. 5 gets all of it because 1, 2, 3, 4, 5 are all coprime to 5. I mean, apart from 5. 1, 2, 3, 4 are all coprime to 5. For 6, we only get 1/6 and 5/6 because 2, 3, and 4 share a factor with 6 bigger than 1, so they also have a simplifiable fraction that was already there. So really the levels here, their size, is the sum through the numbers of how many numbers were coprime to and smaller than each, known as this thing called the Euler's totient function. So we're going to look into that in the future. And this one animation that I got from the Magic Fellow, shout out to him. He also helps me with moderation on the Discord. Will come in handy for a lot of episodes. In the most notable one being the 12 one that is either 5 or 7 hours away, connecting, like draw a line to 5 hours, draw a line to 5 hours, draw a line to 5. Or if I said 7, it would paint the same shape in reverse. A really spiky shape of 5 or 7 hours forward at a time tells us that 5 or 7 are coprime to 12. And that's a fun example due to clocks, and because that's the one that shows up in music theory. But it also tells us that on level 12 of the Farey series, or sequence, we would have 5/12 and 7/12 would show up. 1/12 and 11/12 would also, because those made these polygon shapes that touched every corner. And if we pick another number and hop that many hours on a clock, we're not going to touch every corner in our cycle. So we're not going to get things like 2/12 or 3/12. Those will already have been on a previous level. Now, we will need to make an episode about these at some point because there's so many interesting things to say about them. You can plug these formulas about what the neighbors do, about if there's two terms next to each other, and then we get a new term between them on the next level. You can figure out what that term's going to be. You can have these patterns with the continued fractions that relate to my infinite fractions episode, and you can draw cool shapes with them. They also relate to these things called Ford circles that are really pretty. Ford circles. These things are really cool. So, and we can relate the Farey sequence to these. So that'll be a fun episode someday. For now, let's see what else we got on our roster. So, I better wipe off this whiteboard because the one right over here is a spoiler from one of the shorts I haven't put out yet. Okay. All right, and now the sun is up. Let me grab the chat and see if anyone has any questions I would like to respond to or anything like that. I also want to check how close we are to our 90,000 on here. So this channel really fluctuates on how fast it can grow because it really depends on when YouTube puts my shorts on a bunch of pages or not. And that's just really sporadic and hard to predict. And so it has had times where it got like more than 1,000 subscribers in a day from a short getting like millions of views. But this time it's going kind of slow right at the top of the 89,000s this week. So we need to inch our way past that 90,000 and then blast our way up to the next digit. Although 100,000 is a very overrated number, only useful in our base 10 system, really. I mean, it's better than some numbers of that size, but it is not the most notable number around that size. Still is cool in our base 10 society because you get the extra digit. So that'll be pretty cool. Let's see how close we are. Anyone who has any friends or family who need to learn about math, make sure to send them to both of these channels, because it looks like on this bonus channel we are at 89,930. We are very close to our next, well, to the last stretch before the next digit. Now we're getting a little low on battery, but I do want to stream a little more, so I'll grab my charger in a moment and then we can continue our stream out here. And in the meantime, while I'm gone, maybe I will set up this whiteboard with some type of fun info or game for you guys. Let's see. You know, actually, yeah. Here's what we'll do. Okay, I don't even have the good pen out here. I need to grab a pen from my room. Never mind. Sorry, guys. No puzzle right now. What we're going to do is I'll run and grab the charger, come back, and then we can talk about some more cool math stuff and some more fun stories and stuff. Stay tuned, and for anyone who does have to leave, remember that after these streams, I'll put on some timestamps and chapters of whatever topics and activities we get up to. All right, I'll be back in a sec. right, we're returning. Okay. Cool. Thank you to everyone who stuck around. Let me take a peek through our comments, and before we go on to another specific topic, we will just have a little chat answering a few questions. So, someone's wondering, should -1 be prime? Negative numbers aren't usually considered to be primes. You'd have to specify whether you're going to extend the definition of a prime number, which typically refers to a positive integer, to negative ones. And if you did that, -1 still wouldn't get the credit because 1 and -1 would get whatever traits 1 had if you extended that. Isn't considered a prime typically just because it makes it easier to set up other definitions. We had a choice as mathematicians. Should we call primes the numbers that have 2 or fewer factors, or should we call primes the numbers that have exactly 2 factors? Because 1 is the only number of these positive integers with a single factor. And so mathematicians in the past sometimes defined primes as 2 or less factors, and that would include 1. But then they realized that for some reasons, like the fundamental theorem of arithmetic that tells us every number has a unique prime factorization, it's a lot easier to set up those definitions if 1 isn't included and is called the unit as a separate thing than the primes. So you have the unit, the primes, and the composites. And what that allows us to do is say that every number really has a unique prime factorization, as opposed to 60 being 2 times 2 times 3 times 5 times 1 times 1 times 1, and whichever amount of ones you want to multiply in. 1 being in a prime factorization would make it non-unique, because you could make a bunch of them an arbitrary amount you wanted. And so that's one of the reasons why it's just easier for math to give 1 a slightly different name and call it something like a unit or just 1, as opposed to including it within those primes. So I like to think of prime as meaning 2 factors, because that's the simplest way of phrasing it, but most people, are a little more wordy with it and say a prime is a number whose only factors are itself and 1, which is kind of given to you if you say it only has 2 factors. So I prefer the 2-factor way of phrasing it. Simplifies the definition, even though you do maybe have to think for a moment. Okay, the 2 factors are 1 and itself, but it's enough. If you just say how many factors does something have, 1 factor, you're a unit. 2 factors, you're a prime. More, you're a composite. And there are various ways of then subdividing the composites. We could say these are the composites that are like some are known as deficient versus abundant versus perfect numbers based on how much their divisors add up to. Or of course we can subdivide them based on what they're a multiple of, or whether they're a perfect power or a square or whatever. So you usually have like unit, primes, and then some way of splitting up the composites depending on where you're tackling the problem. Now, looking at some more here, we have someone asking how many clocks I have. Now, I'm going a little backwards on the clock quest because the rain destroyed some other ones broke. I have probably right now about 30 clocks, but I think I had been up to like 40 and then some broke. So I really need to go clock hunting. I don't have a big clock budget, so I need to go to thrift stores and stuff like that, and used places. So I'm gonna go find some used clocks, but I also might, just for fun in February, start like a P.O. box for anyone who wants to mail any clocks or dice. I think that would be pretty fun, but I'm not sure if anyone's actually gonna mail me any broken clocks, but it's worth a shot. So I'll let you guys know if I start that. I might do that in February. Someone asked what's 2 minus 1.9 with a bunch of dots, assuming you mean 1.9 repeating, because if you just mean 2 minus 1.9, the answer is just 0.1. But if you mean 0.9 repeating, 2 minus 1 point infinite nines is 0, because 1 point infinite nines is the same number as 2. Unfortunately, in a system like our base system, and this would be a trait for any positional numeral base like our base 10 system, some numbers have two representations, one of which is followed by an infinite amount of zeros after the decimal that you don't have to write, and one of which is followed by an infinite amount of nines after the decimal. For example, point infinite nines is 1, and also 0.4 and then infinite nines is 0.5, and so on. So it's an unfortunate trait of bases like ours that we're going to have to deal with, that there's a secret second representation of some numbers, including numbers like 1 and 2. So, let's see. Thank you all. Have I tried proving the Collatz conjecture? I have not. I've thought about ways that someday I'll make an episode about that, which I haven't yet, because there's already some good videos about it online, and I wait to make my videos until I have like a unique spin or something new to say about a topic. So at some point there'll be something new I have to say about the Collatz conjecture that could maybe be a hint to people who want to explore it, but I'm not going to dedicate time to it because some people have already dedicated an insane amount of time to trying to crack that, and all the work I would go through would probably be hitting some pretty similar notes to them, because it's one of the most researched problems in history just because of its popularity. And it's not necessarily on my top list of the problems I'm deeply invested in. It would be really cool to see it solved, but not as cool as something like the twin prime conjecture or the Riemann hypothesis or the Goldbach conjecture. There are a lot of deeper questions in number theory to me that I think would say a lot more about numbers if we cracked them. 3x plus 1 is very arbitrary, and so it tells us a lot about the capabilities of proving things about numbers. Like, if we can prove it, what will be really notable isn't, oh, it's true or not. That doesn't really matter for numbers, whether it's true or not. It doesn't tell us that much. But it would be really interesting to see how we prove it, because it would require a new way of tackling proofs about infinite amounts of numbers. There are ways to prove things like there's an infinite amount of primes and other things about infinities, but this type of infinity we haven't been able to crack how to prove with the Collatz conjecture. So it would be more innovative in terms of the proof technique maybe being applicable to future other questions than in whether we get the answer as a yes or a no. So personally, I have not done that, invested time in that, because the ones that, like, if I don't spend as much time trying to crack one of the classic questions in math, because those take a severe rabbit hole and focus on. And I have a more scattered, this topic than that topic than that topic way of doing things. So I'm building a more widespread knowledge as opposed to a super intense knowledge on one topic that it can take to crack a problem like that. So I don't spend as much time trying to crack other unsolved problems as I do with like lesser known ones. If there's some small conjecture I see online, or if I have my own conjecture, that I'll dedicate a bunch of time to looking into. However, out of all the ones that I have thought about ways of trying to crack, I've done a little fiddling around in my brain about things like the twin prime conjecture, because those are ones that, to me, are a little more fundamental to math than the Collatz conjecture. Someone's wondering about pi's decimal pattern. We actually don't know if pi is what we call a normal number. A normal number is a number that the digits appear the same amount as each other if you look at an arbitrarily long stretch. So like if I take the number 0.123456789 and then write out 10, write out 11 as decimal digits and write out all of those, that's known as one of the Chapernon constants. And those ones, not sure how to pronounce the guy's name, Chapernon or something. those constants are normal in that if you look at a close to infinitely big stretch of them, you'll see an even proportion of each digit. We don't know if that's the case for pi. It's actually a misconception that we know for sure that pi contains every decimal string. There's a chance pi never contains 27 twos in a row or something, unless we've already found that in a chunk. But you know what I mean? Something that we haven't found in pi, there's a chance it's not in there. It's more likely that pi is a normal number, that it contains every infinite stretch. But just because a number is transcendental, irrational, and contains an infinite stretch doesn't mean it needs to even have every digit. You can have numbers that are transcendental like pi that only contain zeros and ones. So for all we know, this is incredibly, incredibly unlikely, but it is theoretically possible that there's a point in pi where after that, it's only alternating between zeros and ones. As long as it's a irrational pattern of a certain sort, that would work. So theoretically, incredibly unlikely, but theoretically possible that pi stops having eights in it or something at a certain point. So pi's decimal pattern, I don't care about that much. It's like, who cares about how pi looks in base 10? We decided to write base 10. What I'm more interested in is pi's continued fraction. There are continued fraction representations of pi, a simple one, and then these generalized ones as well, that are these infinite fractions that equal pi by converging to it. And so those are far more interesting to me than the decimals. If you want to see some of those, there's an episode on my main channel called Capturing Infinity with Fractions. And that one goes into some really cool ways of making pi and stuff like the square root of 2 that are way better than the decimal. Like, in fact, the square root of 2 has a continued fraction that has a pattern. And its decimal doesn't. Its decimal is irrational. And it's an irrational number, but it's of a type that its continued fraction has a periodic pattern. So some of them are just so much neater and more close to what numbers are actually doing if you look at something like a continued fraction, as opposed to its decimal representation. If anything, I would be more interested in like its binary representation. Let's see. Someone says they actually do have a broken clock they'd end up sending. So we got at least one broken clock. I think I probably will do that starting February, so I'll let you guys know. You know how I leave like chapters and timestamps in these streams. Sometimes I'm going to be streaming and have some random cool news or activity. So if people can't catch a whole stream, always at least check later to see what all of the timestamps were. And like maybe one next week will be like, I started a PO box or something like that. Because it could be a good time. February's coming. Although if you pay per month, I'm paying for the shortest month. But I was like really stingy with like the ratios. I'm like, I'm waiting for a 31-day month to do this. No, it's probably like on 30-day cycles, but I don't know. No, maybe, yeah, if it's the same day of the month. February, I'm going to get ripped off. I'm going to get a worse rate. So, someone's wondering if x to the 0th power is 1, why is 0 to the 0th power not equal to 1? Well, to note, there are some fields where they decide we're going to let 0 to the 0th power be 1. There are certain types of like combinatorics and stuff where they do as convention let it be that. However, on the bigger scale, if you're not saying I'm in this realm with this convention, the bigger scale we call it undefined, because although the typical rule is that x to the 0th power equals 1, there's another typical rule, which is 0 to the power of anything equals 0. So, what about that rule? 0 to the x equals 0. That rule holds for all the other ones. So we kind of get a clash there. 0 to the 0th power. The 0 at the bottom makes it want to be a 0. The exponent makes it want to be a 1. And so that clash makes us call it, in fact, it's not known as undefined, actually. I believe more commonly called indeterminate. And let's double check that here. But indeterminate is another way of saying the ones that didn't fit with the typical rules of arithmetic. And trust me, people have tried to just be like, oh, I'm going to give it a variable for what it means. You lose other rules of arithmetic when you do that. So shrinking down a little bit, 0 to 0 indeterminate. Let's see. So, indeterminate. Yeah. These are some that are called indeterminate. Although this one's sometimes just called undefined. Some of them are also called undefined. There's overlap in when they use those terms. But these are all interesting looking. Look at this cast and crew of insane numbers. This is like the most insane gang you'd ever come across. This stuff like this will show up in one of the fiction books I'm writing. That's a strange maze of text with many layers that it's not probably going to be the first fiction book I'll be able to publish, but it's one of the most important to my life's work that relates to the numbers 0, 1, and infinity a lot. So, and someone's wondering why 0 factorial is equal to 1. I've actually explained that in a few times before, so I'm going to recommend look up my episode Factorial Fact Frenzy on the main channel. It's one of the fun episodes of a bunch of minutes about crazy factorial facts, and I do go into 0 factorial in that episode too. I think I've made a short about it too, so I don't think I'm going to explain it right here. So, thank you all for those awesome comments. Thinking about other stuff going forward, there's going to be, we're going to be getting more clocks and dice and just audio gear and stuff like that as I prep for grade -2. And I'm going to really need to clean up this place because, as we can see, let's take a little look at the combo class. As we can see, the mini whiteboards are like destroyed by the rain. There's dice all over scattered in the ground. There's clocks in my planter. It's a little chaotic out here. And so we're going to have a little work, me and my friends, in March, setting up for grade -2, probably dropping at the beginning of April. And so my goal is in February, I'm going to be filming some of the craziest main channel episodes you'll ever see. And if you want some previews of the behind the scenes, make sure to check out the Patreon, which I'll be posting a bunch of behind the scenes stuff and some of my music on very soon. Probably post some stuff on there tomorrow. And then we will, throughout March, I will be releasing some episodes and live streaming, but I might have to live stream in my room and keep the back here somewhat secret because I may have to pull a little reset behind the scenes and spend a bunch of work cleaning up all the chaos out here, all the things the rain fully destroyed. And we may need to have some sort of destruction ritual that I may film for the finale because part of the philosophy of combo class here, when someone donates a clock, for example, sometimes one of my friends asks, here, you want this clock on your set? And I'll be like, I do, but here's what you have to know. If you give me the clock, it will probably end up breaking. I'm not going to feel bad if I break it. However, I'll try and make sure that it does some good teaching before, during, and or after that breaking. And that if it breaks, I will try and have that documented on film, and I will try and have it get some cool spinning or hanging or chilling before that in film. And then I think it gets more of a historical place than just being a clock on someone's shelf. So you can donate anything to the combo classroom, like clocks or dice or stuff, that you don't care if it gets destroyed. But you can trust me that I'm not going to just destroy it with the camera off. I'm going to destroy it to teach. And probably not intentionally. I'll probably just break during some incident during the chaotic teaching. So that's something I have to warn some people about, that like if they like want to give me a fancy clock or something, I'm like, you know it's probably going to break, but it will end up going down in history a lot more breaking on film here than on your shelf. So if you want that, you can donate it. So that'll be pretty fun. Maybe if I start a PO box and I can like open some of the packages on stream, maybe. But people are gonna have to be very chill with what they send me. Things like that can go wrong. People like to like prank people and do dumb stuff. So I'm gonna trust you guys to only send me things that are on a certain list, and I'll make the list open-ended enough that you can have fun with what you send me. But it's gonna have to be something along the lines of a clock. Doesn't have to work. Dice, or some type of mathematical toy or game. If you think there's a cool mathematical or scientific toy or game that is totally good to send in the mail, like some science stuff you're not supposed to mail because it's dangerous, something completely safe, something that would never get me in trouble on stream, that you think would be fun here, I'll also trust you guys a little bit if you want to send me something you want to see on the stream. But I'm really trusting you guys, and I'll have to stop doing it if people like send me a glitter bomb or something. So just clocks and dice, folks. So someone's wondering about a home tour. I don't know when I'll do much, but if you look through all my videos, there are some shorts that are filmed in my living room or in other rooms. I've streamed in my room, but you've only seen one angle of it. I'll do more of a tour at some point. I also want you guys to meet my family at some point. So there will be streams at some point that's like, meet my brother, meet my mom, meet my dad. And those streams, you know, you can ask them questions, see what they're like and stuff, you know. So that would be fun. Also, I want you guys to meet my camera people who are super chill. And my friends who pretty much all my friends I've roped in at some point to film something or another. But I have a great squad and a few of them who really help me out on the filming. I pay them, but they very much help me and go above and beyond. And someone's saying no digital clocks. Yes, good point. I need to clarify that. It's not going to include digital clocks. I don't want that, because if it doesn't plug, like a digital clock has to plug in, I'm not going to have like a power strip out here to plug in 5 digital clocks. So it has to, here's the thing. I'll make an episode about this sometime, but what is a clock? There's like a weird it's like 2 types of thing could be a clock. It could be a clock looking thing that like moves in a cyclical way and looks like a clock, or it could be something that tells time, like a sundial or an hourglass or stuff is almost a clock. So theoretically, you can send me anything that fits either of those that looks a lot like a clock. Looks a lot like a clock, or that tells time in some way, not digitally. But it could be either of those. It doesn't have to be both. And also, I'll figure out what other things of your crazy weird scraps might help around here. Mostly, it's going to be clocks and dice, but I guess, yeah, calculators we can throw on. Anyone can mail me a calculator when I open the P.O. box. But, you can save your calculators if you want. Once again, the calculators or anything you send me may be destroyed. But if it is, it will probably be in a historic way. So, pretty soon I'm going to wrap up the stream because I am actually filming today. And we're going to be filming some wild stuff about those pan-digital numbers, which... today I'll probably film the portion of the episode that's just a bunch of fun, interesting pan-digital numbers that happen to have cool traits. And then in a few days, probably film the rest of the episode, which is about how deep this question of what pan-digitalness means on a number line can go. And for anyone who wants to think about it on their own, here's an interesting question for you to ponder. What does it mean to be pan-digital, or to have all the digits at least once in binary? What numbers are or aren't pan-digital in binary? That's something that will come up in the episode, something that you can sick your mind into for now if you want to think about it. So, thank you all for joining me. Feel free to leave any last thoughts or questions. I'm going to wrap up so I can eat some breakfast and then start filming with my boy Carlo. I will do another stream when we hit 90K. I will do one that's specifically a 90K Q&A. So anyone who has any questions that they want me to answer, if you don't know if you'll be able to make that, after this stream posts and I put the timestamps and stuff, later if you want, or no, when I schedule the next one, when we hit 90K, I'll schedule a question and answer stream, and anyone who can't make it can comment in advance on the video, any questions they want to see me answer. And so let's see how close we are. Have we gotten any closer? Let's see. We have not gotten any closer. We are still at about 89,930, but we will inch our way and then blast our way past that 90,000 and that 100,000. This channel isn't that old. It's super awesome we're up here, because this channel, although I've started filming the shorts that are on this channel last mid-April, but I didn't start putting them on the YouTube shorts until a few months later. The first video I put on this channel was on September 1st. That means that it's been less than 5 months I've been posting on this channel. And I've been posting on the main combo class channel just a few months more than that. So thank you all so much for coming here, enjoying what I have to say and helping me build this community. We got a lot of awesome people chatting in the Discord and some really cool stuff on the subreddit too. Also, extra shout out to the people supporting me on Patreon. Like I said, I didn't put as much bonus stuff in January because I was super busy, but in the next day or two, I'm going to be putting up some more fun behind the scenes. And next month, I'm going to be putting out a bunch of the soundtrack rough cuts that I have now, just the unmixed versions of all the beats that at some point I'll mix and release officially. They're like my combo class soundtracks. And there was a squirrel. I hope that was in there. I love when the squirrels run by here. That's part of why I have the outdoor classroom. So, thank you all. Thanks to the birds. Thanks to any aliens or gods or simulation creators who might be watching. Thank you to all the mathematical patterns we know exist. And I'll catch you all very soon. In the meantime, make sure to check out all those new shorts I've been putting out on this channel. Make sure to check out the awesome main channel episodes, like my base 2i one. And also, tell 70 of your friends about this channel, because we're really close to 90K.